Hey guys, today we're taking a look at equations for lines graphed in the coordinate plane. Now, since almost every line passes through the y-axis with a certain steepness or slope, then we can write the equation of a line in what's known as slope-intercept form. Now, those two important pieces of information are exactly that. The y-intercept, where that line crosses the x-axis, and its steepness. In other words, its rise over its run. So let's take a look at today's notes now. The slope-intercept form of a line follows this template, y equals mx plus b. Now, the two pieces of information that we need to know are the m and the b. Now, remember, m represents your slope, and you can find that from 2 points on the line. And the b represents the y-intercept. In other words, where it crosses the y-axis. And you can also find this by looking at the graph or by substituting a pair of values and solving for that missing value for b. All right, now also keep in mind parallel lines have the same slope, whereas perpendicular slopes are opposite reciprocals. For example, 1/2 and -2/1 would be opposite reciprocals. So lines that have these two values for slope would be perpendicular to each other. The slope of a vertical line goes straight up and down, remember, and therefore this is an undefined slope, whereas a horizontal line is like the horizon or the floor, and it has zero slope. Now, every vertical and horizontal line are perpendicular to each other, whereas every pair of vertical lines would be parallel, or every pair of horizontal would also be parallel. All right, let's take a look at a few examples for today. Sometimes we'll be given equations and we'll be asked to figure out if these two lines that are described by these equations are parallel or not. In our first example, we see we have y equals 2x minus 2 and y equals 2x plus 4. Well, if you keep in mind our little template for slope-intercept form, y equals mx plus b, we are looking for the coefficient on x to represent the slope. In both of these two lines, their slope is 2, so I'm going to say that these two lines are going to be parallel to each other. They have the same slope. In our next set of lines, we see that we have y equals 0.4x minus 7 and y equals negative 0.4x minus 7. So our slopes here are 0.4 and negative 0.4. However, they do have opposite values. However, they're not reciprocals, so we have to say that they are not either parallel nor perpendicular. So we'll just say not either. All right, our next set here, we have y equals 2/3 x minus 8, and then we have 3y minus 2x equals 6. So this second equation gives us a little bit of trouble because we need to find y and get it in this slope-intercept form. So we're going to rewrite our equation by moving this negative 2x over to the other side of the equal sign, and that gives us a positive 2x plus 6 on the right, and then we're going to divide both sides by 3. When we do that, we get the equation y equals 2/3 x plus 2. So you can see here I have a slope of 2/3 and a slope of 2/3. So these two lines are going to be parallel to each other. Next, it says tell if the following pairs of lines are perpendicular or not. Well, here we have the equation y equals 1/2 x minus 2 and 2x plus 4. So if I write 1/2 and 2 as my slopes, I do see that they're reciprocals of each other. However, they're not opposite in value. In other words, they're both positive. So these are not perpendicular to each other. All right, our next equation here, we have y equals negative 3x minus 7 and y equals 1/3 x minus 7. So I'm going to write out my two slopes. I have a negative 3 and I have a positive 1/3. Well, these are both opposite in value and reciprocals, so I say yes, these are perpendicular lines. All right, my next pair, y equals negative 1/5 x minus 8, and then again I have this 2x plus 10y equals 30. So I need to solve this second equation for y. I'm going to start by moving over my 2x. I have 10y is now equal to negative 2x plus 30. And now I'm going to divide both sides by 10. When I do that, I will have the equation y equals negative 1/5 x, and that's what we get when we simplify negative 2 over 10, plus 3. So I have negative 1/5 is my slope for this line, and negative 1/5 is my slope for the other line. So they're not perpendicular, rather these two lines are going to be parallel. All right, let's take a look at example 3. It says find the equation of a line that is parallel to the line with y equals 2x minus 1 and passes through the point 2, 4. All right, so I'm going to go out into my coordinate plane. I'm going to plot that point 2, 4. Here it is. And I know that the equation I want to write has to have a slope of 2. All right, so if my slope is 2, I know that I'm going to rise 2 and run 1. This is what it means to have a slope of 2, or I'm going to go back 1 and down 2. So here are the points that are lying on this line. I can just use my slope to generate those. Now I also see that it crosses the y-axis here at 0. So remember, in my slope-intercept form, I need to know two things. When I write the equation of a line, I need to know slope, which I already know, and I also need to know my y-intercept, which I just found out. So the equation of this line is y equals 2x plus 0. All right, in our final example for today, we want to find the y-intercept slope and determine the equation of this blue line that's graphed here. So we see that we have these points that are on this blue line. I'm just going to mark in a few additional ones here. And if I count the rise over the run between those 2 points here, I see that my rise is 2 and my run is 1. So the slope of this line is equal to 2 over 1, which is really just 2. How about the y-intercept? Well, here's my y-axis. If I count up from my y-axis, I have 1, 2, 3, and 4. So it looks like my y-intercept here is 4. Now I can write the equation of my line, and it follows my template. Y equals my slope times x plus my y-intercept. Now I want to write the equation of a line that's parallel to this line and passes through the point 1, negative 2. So if I move to the right 1 and down 2, here's the point 1, negative 2. If it needs to be parallel, I know that my slopes are going to be the same, so I can use my slope here to do my rise over my run and plot more points on this line. So I see here are the other points on the line. If I go to the left 1 and down 2, this point is on the line. And again, I'm just going to use the idea of slope to generate those points. And now I have the equation, or I should say now I have my line, and now I want to write the equation. So the equation here is y equals 2x, because my slope needs to be the same, plus my y-intercept. Well, my y-intercept looks like it's negative 1, negative 2, negative 3, negative 4. So plus a negative 4 is the same thing as minus 4. All right, the last one here we're going to leave for class discussion. Finding the equation of a line that's perpendicular to this line and passes through the point negative 1, 2.